in example 2, it says, here's the graph of g of x. Sketch the graph of negative g of x. So first of all, I make a note that that's outside. That'll be a vertical reflection, which means it's going to change your y values. Your y values are going to get multiplied by -1, reflecting it over the x-axis. And so if I look at some key points on my graph here, I have 1 comma. Okay. First of all, can you see yourself labeling that as 1 comma 3? Because it went up 3 blocks. We have to be careful to look at your axes that you're actually going up by 2's. But when you flip that down on my new graph, which I'll do in green here, I'm going to have 1 comma -6. And here I have 3 comma 2. So when I flip that down, I'm going to have 3 comma -2. The next thing that's important to recognize is when you're flipping over the x-axis, there's always one point that stays exactly the same. And that's going to be your x-intercept. Why? Because your x-intercept is something comma 0. I don't even know what the x value is, but my y value would be 0. What happens when you multiply 0 by -1? It's still going to be 0. Does it make sense that that point is not going to change? So now when I graph this with that reflection, there's my new graph. It says state the domain and range of each function. Well, I'm going to use set notation here. The domain of the red one went on forever. The range went up and down forever. With the reflection, it's still everything. So nothing changed with the domain and range, but we can see our graph reflected over the x-axis. All right, this will be the last question we'll do for today. Your questions you can do are 4, 5, and 6, 10, and 11.